Good morning, Blue. And that was EMA going out to Dave with a congratulations on your first wake up in space.
And good morning, Houston. The Blue Shift is up and awake and ready to work after that little bit of international flavor, ready for our first full day in space.
We're now receiving live video from inside one of the mini experiments inside the Space Hab Research Double Module. This experiment is called the Space Technology and Research Students Payload, which is comprised of 6 experiments that were set up by students from 6 different countries. The views are switching between some of the investigations inside this experiment. Students from Australia are hoping to examine how spider webs are produced, as well as the mechanical properties of web filaments and microgravity. And students in China are studying the development of silkworm larvae, pupae, in adults, as well as the production of silk and the cocoons that are spun. Students in Israel are examining the production and geometry of crystal fibers in microgravity in order to better understand their formation here on Earth. And students from Japan are examining the effects of microgravity on a closed aquatic ecosystem using Medaka fish embryos. Students from Liechtenstein are studying the behavior of carpenter bees in microgravity. And students from New York in the United States are studying an ant colony in microgravity. These are all part of the Space Technology and Research Students Payload, which is an international educational payload in which students from these 6 different countries developed biological experiments in order to promote an interest in scientific careers.
And Columbia, Houston for Mike, just for information, we have the good video down here, and we like what we see.
Okay, if that's the case, then we go ahead and open the MEDEX door.
Sounds good.
This is Mission Control Houston, Payload Commander Mike Anderson working through checkout procedures of the MEDEX experiment, the Mediterranean Israeli dust experiment inside Columbia's payload bay.
Space Hab Columbia, putting arms ergometer set up in work.
Okay, Dave, we copy. We know you can't wait to get on that bike.
Now you can see the lid of the getaway special canister that MEDEX is located in opening up. Inside the lid, there's a coated quartz window that a video system can be used to look at the aerosol particles that may be one of the primary agents that can offset the climate warming induced by the increase in the amount of atmospheric greenhouse gases. The video of this experiment will be used to measure the small particles or aerosols in the atmosphere over the Mediterranean Sea and over the Atlantic Ocean off the coast of the Sahara Desert in Africa.
Mission Specialist Mike Anderson reporting to the Shuttle Flight Control Room and the Payload Operations Center here in Houston Mission Control Center. That data take is underway on the MEDEX experiment. The look at the experiment to measure small particles or aerosols in the atmosphere over the Sahara, the Mediterranean Sea, and the Atlantic Ocean. We're seeing some of this downlink on that data take on NASA television now. These aerosols can have an impact on the Earth's climate. They can either absorb or reflect sunlight. And understanding them better will help scientists to determine more accurate climate models.
Well, at the end of our first observation, I would like to say congratulations to the whole MEDEX science team. They've opened really a new chapter on the study of dust and aerosols, how they contribute to the Earth's climate, in particular global warming. And it's a big day for the Israeli science community who've opened a new chapter, now participating in human spaceflight. And I'd like to add my personal congratulations to Yoya, who's come a long ways to see this day. So congratulations to MEDEX.
Hey, Doc, we appreciate those great words. Thanks. Elementary Honors Choir with the beautiful Laura Husband as a featured member.
Thank you very much, Scorch, and it's really great to hear that music and also know that Laura was singing with the choir, and it's really nice to be able to have a nice reminder of our family. So I'd like to say hello to Laura and also to my son Matthew and my wife Evelyn. And we're having a great time up here, and we just appreciate all your support. Thank you very much.
This is Mission Control Houston. We're back with live downlink from Columbia. This shot shows Kulna Chawla, the mission specialist, working with the zeolite crystal growth experiment. She's working with samples that are being melted and processed in order to produce hopefully more pure and more uniform zeolite crystals than can be grown on Earth. The process takes advantage of the microgravity of space. This experiment seeks to produce larger and more uniform zeolite crystals than it's possible to produce on Earth. Possible application of this technology would be in catalysts for the oil and chemical industries, as well as perhaps commercial film products. In this live downlink on NASA television, coming down for the scientists in the Payload Operations Control Center, is from the FAST experiment, the Facility for Absorption and Surface Tension. It's a European Space Agency experiment, and it's designed to measure the response of surface tension to control changes in the surface area of bubbles or droplets. The experiment's designed to be almost fully automated and requires minimal crew time.
Houston, Columbia, full door opening is coming now.
We copy.
Commander Rick Husband reporting that the door is being opened on the SOLS experiment on the Freestar pallet. That pallet in the payload bay of the Space Shuttle Columbia. SOLS is looking at a new instrument for measuring ozone in the Earth's atmosphere. Once the door of that canister is open, the SOLS experiment can begin taking its measurements of atmospheric ozone. You're looking at a live view of the mechanics of granular materials experiment in the Space Hab. This experiment being done by mission specialist Kalpana Chawla. It involves a compression of sand crystals. Researchers hoping to better understand why sandy soils sometimes have a quality known as liquefaction, and that they behave much like a liquid during earthquakes. Researchers are hoping that by better understanding this liquefaction that sometimes occurs in sandy soils, they'll be able to better design buildings that will be sitting on top of these kinds of soils and prevent damage that could occur during earthquakes. The grid lines you see will help the researchers better understand how the sand is being compressed and also how it's deforming. Although this process is occurring very slowly, if you look at the grid lines, you can see that the deformation or deformation is beginning to occur as this sand sample is compressed. Again, this experiment being done by mission specialist Kalpana Chawla in the Space Hab Research Double Module in Columbia's Payload Bay. You're looking at the Astroculture Growth Chamber. Also, you might hear the crew calling it the AST experiment. This is one of the commercial experiments being done by Space Hab. In this particular experiment, they're looking at the impact of microgravity on plant oil development using this plant growth chamber. The main objective is the development of both new cosmetics and food flavors for a commercial company. This company hoping to produce new scents or fragrances using these flowers. Flowers grown in space often have different fragrances than they do here on Earth, and this enables research to literally create scents that are out of this world. You're looking at live video from one of the student experiments in the Space Hab Research Double Module. This particular experiment from a school in the United States looking at ants and how they behave in microgravity. You can see that the ants actually tunneling through a colored gel. This gel acts as a tunneling medium for them. It also provides food and water. We're currently cycling through all the STARS experiments. There are 6 experiments as part of this payload from 6 different countries. Australian students are doing an experiment with spiders. Israeli students are looking at crystalline fibers. Some students from Liechtenstein are looking at carpenter bees. And as we saw, the United States students are looking at ants. And students from China are looking at silkworm larvae. And finally, some Japanese students are looking at small fish. The students designed these experiments and loaded them into the Space Hab Research Double Module. They'll also get the results of the experiments and do an analysis.
Columbia, Space Hab.
We're continuing to cycle through the 3 different views of the mechanics of granular materials experiment in the Space Hab Research Double Module. You're looking at a sand column that's being slowly compressed. If you look at the grid marks, you can watch the deformation that's occurring as this sand column is compressed. The sand on the column is Ottawa sand, which is a natural quartz sand with very fine grains, and this sand is widely used in civil engineering experiments and evaluations. The Space Shuttle Columbia now flying over that portion of the Earth that's experiencing nighttime.
We copy KC, MGM deactivation complete. Thanks so much.
If you look at the bottom picture of the Earth, you can see flashes of a thunderstorm occurring. Also, that thin white line with a little bit of dark moving down toward the surface of the Earth is the Earth's atmosphere. And here's a better view of those flashes.
All is complete with muscular 1, and I'm putting arms power down in work.
We copy that, Laurel. Thanks so much for the status.
This is an excellent view also of the limb of the atmosphere, and it's through this limb that the SOLS experiment has been making its ozone measurements. It looks at the sun through the limb and is able to determine how much ozone is in the atmosphere, beginning with that thin white line you see and moving toward the surface of the Earth.
Here we are on the flight deck just prior to liftoff, and there's liftoff. You'll see the sun. Oh, there's liftoff right there. The first one was the engine starting up. You see the roll program here as the sun kind of shines through the cockpit. Right there, the orbiter is going through its roll maneuver, roll program, and the vehicle just flew beautifully. We had a great ride. We had brilliant sunshine coming in through the windows in the front, and it was just a fantastic ride all the way up. Some people have said that sometimes Columbia, they have to do a lot of work on it on the ground, but when it gets in space, it just does wonderful, and we think that's because she just loves to be in space, because we've got a great big vehicle right now, and we're really enjoying it. As you can see again on the lower left, there's Mike Anderson coming up from the middeck, preparing for the ET photo that we're going to do once we pitch the orbiter up. And Dave Brown, there on the right, is getting out of his seat and getting his seat prepared to take some video of the external tank. Mike's taking pictures with the F5 camera, and Dave there is getting his parachute out of his seat, kind of getting everything out of the way so that he can then fold his seat down and get in a position to be able to take pictures of the external tank. See, Willie and I are congratulating each other up front there, and we were very happy to welcome 4 new astronauts into the community with Willie McCool, Dave Brown, Laurel Clark, and Elon Ramon. So you can see Dave getting all squared away and ready. Mike handed him the video recorder, and Mike comes on up into the cockpit, get himself into position to take those photos. You can see with the launch and entry suit on that it's a bit of a challenge coming up and maneuvering and everything, but they're able to get in position anyway. Dave's making sure he's got all of his settings correct on the camera here, and then getting ready to take a look outside the window and film that external tank. We've got some clips of the external tank coming up here shortly. There's a good shot of the external tank just shortly after we pitched up, and we're looking at it through the overhead windows of the orbiter, as you saw Dave and Mike getting ready to do earlier. And you can see every once in a while some ice particles that are floating across the screen. And here now with some of the contrast in the clouds, you get a sense of the kind of speed that we're going here after MECO. Meanwhile, inside the cockpit, Kalpana Chawla, MS-2, is busy helping myself and Willie get all of the checklist items done before we can get ourselves set up for the OMS-2 burn. And here you can see inside the cockpit, just prior to OMS-2 ignition, you'll see right there is where we got the ignition. And here in just a minute, I'll hold my cue card up and let go of it to give you an idea of the kind of acceleration that we're experiencing at that point. We're on the dark side of the Earth right here in the night portion of the path. There goes the cue card floating back. And we had an excellent OMS-2 burn and a great ride into space. And the rest of the day was super, and we've had a super day today, and we look forward to sending you some more of these highlights throughout the mission. Thanks a bunch.